Hello everyone, today I am here to explain the Radix sort. Radix is nothing but base. In numbers 0 to 9 is considered as base, whereas in alphabets A to Z is considered as base. Radix sort is nothing but an integer sorting algorithm. It sorts the data with integer keys and it groups the keys by individual digits based upon its place value. Radix sort uses counting sort as a subroutine to sort an array of numbers, and it is also known as bucket sort algorithms. And Radix sort is a non-comparative sorting algorithm. Into the topic, what is Radix sort and how it works, and its algorithm and time complexity and program and its output. Sort is a linear searching algorithm. That means it sorts the technique. Its sorting technique. It sorts the elements by first grouping the individual digits of the same place value. Place value is nothing but, we all know that place value is nothing but ones, tens and hundreds. It sorts the elements according to their order, according to the increasing order from 0 to 9. And sorting is performed from the least significant digit to the most significant digits. That means right to the left. Ones to the hundreds, it sorts the elements from 0 to 9. This is the technique of the Radix sort, and it is also known as the bucket sort. Why? Because we consider the passes from ones, tens and hundreds. For every pass we need the 0 to 9 values, and that is needed, that is called as the bucket. Let us know how Radix sort works. Let us suppose consider an array like 23, 788, 121, 45. Consider the number of dates, random dates with 3 digits or 2 digits or single digit numbers, and start the sorting according to the least place value, ones, greater ones, tens, hundreds, from the right to the left. Arrange the digits from their 0 to 9 in their respective significant values, and then we'll get the sorting order. Then this program goes until the last significant digits, and here we can see our array into consideration. We sorting the different number of digits based upon its place value, like up to the 0 to the 9. On the first box we can see the units place. It's sorting the digits from 1 to the 9 up to the 0 to the 9. So that is our array 121, 1, 432. It will be sorted upon its the ones digits. And next box we can see that the digits that can be arranged in tens place according to the value 0 to the 9, increasing order. And later it moves on to the hundreds digits 0 to the 9, and then we will get the increasing order from the sorting order according to their numbers considered array. So that's why arrange the digits in respective place and move on to the next place value until you reach the final one. There we will get the sorted order. Let's get into the algorithm of the Radix sort. Take an array of the Radix sort, and there will be the maximum number of digits in the largest elements. That much of buckets will be required. That means if there will be 3-digit number, we will need the 3 passes to compare the values of the place values of the numbers. So create the bucket size of the 0 to 9, and for the we are going to call the function. Now consider the for loop. For I is equal to 0 to the I less than the I plus plus. D is nothing but the place value of the digit. And now sort the elements based upon the ones, tens and hundreds places. Again from the calling, counting sort will place the major role. Counting sort is nothing but a sorting algorithm that sorts the elements of an array by counting the number of occurrences of each unique element in the array, and that count is stored in an temporary array, and the sorting is done by mapping the counter as an index of the auxiliary array. Let us suppose and take the counting sort and arrange the take some consider the array and these index values. That means how many number of elements will be in this array, that much of index will be given, and find out the maximum element, and it will be the maximum from the given array, and use the if condition, check the array of the first number with the second number. Then from this we will get the maximum of in this array size. Then initialize an array of length maximum plus 1 using the for loop for equal I is equal to 0, I less than size. Then we can move the increment the length of the array size by plus 1. This store the count of each element and the respective index in the count array. For example, if the count of the element 3 is 2, then 2 is stored in the third position of the count array. If suppose if the element 5 is not present in the array and 0 is stored in the fifth position, and store that cumulative sum, that means add the one by one of the sum of the elements of the count array, and it helps in placing the elements into the correct index of sorted order. That's why we used this count of I is equal to count of I plus I minus 1. We have to add the all the numbers till we reached the highest index by one before the one. And now for the comparing from the ones, tens, the hundreds, we have to move from right to left, so we have to decrease the size. That's why we use the I is equal to size minus 1. I will be greater than 0. For sorting, we have to know the digits of units place, tens place and hundreds place. For that we have the technique like A of I mod 10 will gives the units place of the number, and A of I divided by its place, it will be 10th place, will put by A of I by 10 mod 10 will gives the tens digit, and A of I divided by hundreds place, 100 mod 10 will gives the hundreds place of the digit. It will be 432. We will acquire the digit number 4 by doing like that. And we have to move from the left to the right, so that's why we will place the minus 1, and that will be collected from the, that will be considered as the output array, and it will be stored in A of I. Let us suppose consider output will be stored in A of I, and count of A of I divided by place mod 10 minus minus, so it will arrange the whole digits, it will sort the whole digits. So that's why we'll take in this, and those values can be stored in this A of I. Let us know about the time complexity of the Radix sort. Radix sort uses counting sort as an purpose on each digit, and each pass over the n digit numbers will take up the O of n plus b time, and there will be d passes total, and that means this algorithm requires the number of passes which are equal to the number of digits present in the largest number among the list of the number. Therefore, the total running time of the Radic gates will be d star n plus b. Here d is nothing but the base. Base is nothing but the numbers will consider base is nothing as 0 to 9. And the n is number of numbers, that means how many numbers in this array will consider as the n numbers. And b is nothing but the highest value, that means index is nothing but as b. Let's get into our program, and we'll all know that in C we'll use the header file as hash include stdio.h, and we have to store the maximum value first in this array. So function get max pass the array like integer n and the number of digits, and there will be the maximum number in this array, and we will consider a variable like int max to store that maximum number. For we are going to call the function now. For that we will require the for loop int I equal to 1, I less than I plus plus, and based upon the numbers in this array, one will compare the other, and there will the maximum array of it. So return max will store the maximum number in the array. Now we will come to the counting sort. Counting sort will be given like in the index number, and there will be number of places from 0 to 9. There will be how many digits will give that much of index. and to know the position like ones, tens, hundreds in the counting sort, we will require, like just now we told in algorithm, like a of 0 divided by its place mod 10 gives the place of the digit, and we will call the function in the counting sort like I equal to 1, I less than size, I plus plus will move on to the digits. So in comparing the digits like with using this a of I divided by place mod 10, we'll sort the all digits, and when we'll use the if loop, there will be a comparison between the numbers and the maximum number will be there in the a of I. And now we'll move on to the count array to sort the total whole array. Moving to the counting sort for the comparison, we'll take in the for loop int I equals 0, I less than maximum, I plus plus. And now we'll in just count sort, we'll do that, take one number, take the place value of that number and increment the value by 1, and we'll get that count of I equal to count of I plus I minus 1. We'll get the cumulative sum of the all numbers, and just we'll only concern with the place value, the digit, and not the whole number. For that we have to move on from the ones place to the hundreds place to check the value of the digit to sort the numbers. Now to the to place all the sorted numbers, we'll take the output array, and a of I divided by its place mod 10 minus 1, we will move from the left to the right place. So we have to increment and collect the whole numbers, so that's why we will use the count of minus minus, and these all will be stored in output array. And to get the maximum element, int max get max array of size, we'll use this, and we have to change the position of the value to divide the number, so that's why we will use the place into 10. It will give us as the, we will move into the hundreds place, and again we will move into the thousands place. For that this function will be called for this. So for that we have to the right place its position first is equal to number 1, and maximum divided by its position will have to be greater than 0, and position have to be multiplied by 10, not divided by 10, we have to multiply its number by 10. So from when only we multiplied its number by 10, we'll move on to the tens place and hundreds place, and those all values will be called in that function. Counting sort array size place will be noted down into that array, and after all the sorted elements, we'll print that array with print a percentage d array of I. We'll print this array, and based off on its digits comparison of the respective place values and tens hundreds place, we'll get the output of array like this.